Hey guys, this is the second part of our video going over example 5 and example 6. Once again, I wrote a little thing here just to state that summations are essential in calculus. If you get anything from this lesson, it is going to be from this section. You guys have seen it, but you haven't seen it since Algebra 1. And the first couple problems are very, very simple. And then what's going to happen is it's going to get a little bit more involved as we go along with this, the next 3 lessons. So with this, the sum of the first n terms, that means we're adding them together, is represented by summation notation. Okay, I'm going to explain a little bit what summation notation is. This is going to be the number of terms, or the final term, final input. Okay, and this is going to be your initial input, or your initial term. Or did I say that correctly? Yeah, it's initial term. Start from 1, go to 7, that kind of idea. So when we're looking at it, we have this a sub I, and essentially we're going to plug in 1, then 2, then 3, then 4, all the way until we get to that final term n, and then we're going to add them all together. So for example, if I were to give you guys a sum, a sum from 1 to 3 of a sub n, or a sub I, I would get a sub 1 plus a sub 2 plus a sub 3. That would be it. Why? Because this is going to be your final value you're going to be inputting. Okay. We're going to get to infinite sums when we get to calc, and that's going to be the idea of what happens if we add this value all the way until we get to infinity. If it's a fraction, if it is a rational function, if it is a polynomial, what would be the case? And it's not always going to be when you add all the numbers to infinity, you get infinity. Sometimes you're actually going to get something that's going to converge. So with this, I'm going to do example 5 with you guys. This is going to be very important. Please take notes on example 5 and 6 as you guys go along. I'm going to do a couple of these with you. I'm not doing all of them, but the idea is when we're looking at this, we want to identify a few things. We're going to be plugging in from 1 to 6. So what that means is when we find this sum, what's going to happen is we're going to have 1 squared plus 1. That's our first one. Then we're going to plug in 2. 2 squared plus 1. Then we're going to plug in 3. 3 squared plus 1. Plus, once again, it's a sum. That's why we're putting a plus there. 4 squared plus 1. Plus 5 squared plus 1. Plus 6 squared plus 1. Okay, so with this, we're going to get all these values, and then we're going to get our final answer as a result from it. And when you guys go through and you start to answer all of these, we're going to get, for each of these, we're going to get 1 squared plus 1 is 2. 2 plus 2 squared plus 1 is 5. Plus 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 5 squared is 25 plus 1 is 26. And then 6 squared is 36 plus 1 is 37. And when you add these all together, you're going to get 97. Okay, so this sum is going to be equal to 97. Okay, the same thing's going to happen in B. I'd like you guys to please try out B as well, but I wanted to talk about C for just a little bit. If you guys are looking at C, one of the things you guys should notice is there is no I value here. There's no I. So with it, if you guys are taking a look, since there's no I value, what's going to happen is we are going to be plugging in these terms, and since there's no I value, we're just going to get right away 3. If we plug in 2, there's no I, so it's still going to be 3. If we plug in our next one, we're going to get 3. Then we're going to get 3. And then we're going to get 3 again, right? So for each of these, we're going to get 3 5 times, which gives us 15. Okay. So with that, I want you guys to go ahead and take a moment, finish off example 5B, and then try out checkpoint 5 for me, please. So go ahead and take a minute for that. All right. The next thing I wanted to do is we're going to go ahead and take a look at example 6. This now, we're going to be going backwards. Okay, we're going to be taking and we're going to be writing out our sum. Why did that do that for me? Oh, well. We're going to write out our sum I equals all the way to whatever our final term is, and then we have to write our equation off to the side. So the first thing I wanted you guys to notice is what's changing. So if we notice what's changing, we're going from 1 all the way to 7. So what's our first term going to be? It's going to be 1. What's our last input we're going to have? It's going to be 7. And then we have to write a general form. So we have to think about it this way, where what are we plugging in to get each of these values? Well, we're plugging in 1, right, into this value. What doesn't change? This 3, correct? So we're going to get I to the power of 3. Okay. Once you guys do it, after you guys try to figure out this puzzle, what you're going to do is you're just going to plug it back in. If I plug 1 in here, I get 1 to the power of 3. If I plug in 2, I get 2 to the power of 3. If I plug in 3, I get 3 to the power of 3. Then if I plug in 7, I get 7 to the power of 3. So that would work for me. Okay, I'm sure there's a methodical way to go about it, but this is, once again, one of the more straightforward ways to go about this entire thing. Okay, for the next one, what we're going to do is this one already has a value. This is going to be going from, if you're thinking about it, we're going to go all the way to n. Okay, we already have this first portion for us, 1 over 3 to the power of n minus 1. Or we can make it I. That's actually the way we should do it, I. So we know our final term, we're just plugging in our final input, we're plugging in n for that I value. Let me go ahead and erase that and make that look a little nicer. So we're going to have n, or I, minus 1. Okay, but we have to think about what our first term is going to be and then check to see what's going on. So it looks like each time we are going to be dividing by 3 again. Okay, so what value for I would I have to have so that I would get 1 here? So what number would I have to plug in? If I plug in 0, I get 3 to the power of negative 1, which would give me 3. That wouldn't work. What about if I plug in 1? What's 1 minus 1? 1 minus 1 is going to give me 1 over 3 to the power of 1 minus 1, which is 1 over 3 to the power of 0. And what's the power of 0 give me? Doesn't that just give me 1 again? So 1 divided by 1. So in that case, it does work. So my initial term is not going to be 1 in this case. It's going to be, well, actually is going to be 1, just like in our last case. Because when we plug it in, we get 0. I was about to say 0. So what I'd like you guys to do is please go ahead and take a look at checkpoint 6. If you guys have any questions about what's going on, please take a screenshot, a picture of the video, wherever you're at, or of your work, and send an email directly to me, and I'll try to get back to you during my office hours. Okay, I hope you guys have a great day. Thank you very much for your time.